The year is 1999, September 23rd, and NASA loses an 125 million Mars Climate Orbiter spacecraft after a 286-day journey to Mars. The problem? SI unit miscalculations and conversions. The manufacturers were calculating, and when they were calculating, they used imperial units, so yards, inches, and so on and so forth. Well, NASA expected the metric units, meters, kilometers, seconds, etc, etc. And so in mechanics, to prevent errors like these, we have standardized units that we use that make really calculations and passing on information easy, and some formulas also just will not work without the right units. So what exactly are these units and what are they used for? So, well, I guess we can start with one of the commonest one. We can start with distance. Measuring distances or displacements. The unit we use for this is meters, often abbreviated as M. Then there's time. We're not going to use hours, we're not going to use minutes, but we're going to use seconds. So that's often S, sometimes SEC, but in general for mechanics we'll just use S. And then finally, we have not talked about this, but we'll also have mass, which will be in kilograms. And these are the units we'll be using for all our problems. So if we have the problems given in another format, we'll need to convert them first of all to a format that we can use, that will work in our equations. Then we've talked about velocity. Why do we not have SI units for it? Well, that's because when we talked about velocity, when we talked about speed, we had a formula that we used for them. We said that speed is how much, when you think about speed, speed is just how much distance you cover in a period of time. If you're moving faster, you're just covering a bigger distance for a shorter time. So we're just going to get the units for distance. What are those? Those are meters. And what are the units for time? Seconds. And that's why our unit for speed is actually going to just be meters per second. Meters per second. Often in mechanics, we're going to use the indices rules. Well, if you know what 1 over k is in indices, we're using our indices. Well, they simplify solving indices. We can convert that to something like k to the power negative 1. That's the same thing as 1 over k. Or k to the power negative 2 is the same thing as 1 over k squared. So it's like the letter goes to the bottom and then the power becomes a positive. So instead of having meters out of seconds, we're going to have meters and then seconds to the power negative 1. And these will be the units we use for speed, but they'll also be the units that we use for velocity, because the unit for displacement is also meters. Now we need to be able to convert metric units, and the most common measurement we'll need to convert might be kilo. Maybe let's look at distances. We'll have kilometers, which is not an SI unit. The SI unit is meters. Well, we're going to convert them mostly to meters. Oftentimes you might have data given in centimeters. Centimeters, and sometimes also in millimeters, though that's not really often, partly because millimeters are like really small and we're mostly working with larger objects here, or objects that travel over longer distances, but you could possibly have them. So kilo, and then we've got meters, then we've got centi and milli. Well, these are some important prefixes that you must be aware of. You can probably get a full list of prefixes. There's kilometers, there's hectometers, there's decameters, there's meters, then there's deci. For deci we're going to use a small letter, decimeters, then centimeters, then millimeters. Then there's a lot more stuff down here and a lot more stuff up there. We've got picometers, we've got nanometers, but we're not really going to use those in this syllabus or in this series. These are the main ones we're going to use. Now a kilometer, we're going to relate all of them to meters. A kilometer has 1,000 meters, sometimes 10 to the power 3 meters, and a kilogram has 1,000 grams. But for kilograms, we'll need to be converting back to, for masses, we'll need to be converting to kilograms, not to grams. And then for centimeters, 1 meter has 100 centimeters, and then 1 meter has 1,000 millimeters. Those are the most important conversions here. I don't think I need to give you, we can talk about it anyway. A minute is 60 seconds. A minute is 60 seconds. And an hour, 1 hour is 3,600 seconds. Where does that come from? Well, a minute is 60 seconds, and we've got 60 minutes in an hour, so we're going to get 60 times 60 to get to that. And that's quite important. As we talk about more and more of these measures, we'll talk about forces, we'll talk about weights. We'll just from these units that we have here, just using kilograms, meters and seconds, we'll be able to get the units for anything else.